Okay, 8th grade, this is elimination video number 2. Remember, we're using LOAS to help us remember how to solve by elimination. We're going to line the equations up. We're going to look for opposite terms. If we don't have opposite terms, we'll create opposite terms. We'll add the equations together to eliminate one of the variables, and then we'll S sub in to get the value of the other variable. The first example I'll do in this video is system number 12. It looks like this. 2x plus 10y equals 2. Equation number 2 is 3x minus 5y equals negative 17. First, I look for L. Are these equations lined up? I have my x terms stacked, y terms stacked, constants stacked. So yes, they are lined up. Do I have opposite terms? There's 2x, 3x. Nope, those are not opposite terms. What about 10y, negative 5y? Nope, they're not opposites. So if I don't have opposite terms, I need to create opposite terms. Now there are a couple different strategies that you can go about solving this. You could say, okay, 2, the coefficient of this x term is 2, coefficient of that x term is 3. I know a common multiple between 2 and 3, that would be 6. I could get this to be 6x and that to be negative 6x. That way when I add these equations together, those terms would cancel out. I could do that. Another way you could go about this is saying, look at the y terms. This is 10y. Can I get this term, negative 5y? Can I get this term to be negative 10y? So that when I add these, this would be 10y and that would be negative 10y, and they would eliminate. They would cancel each other out. Yeah, I can. I can get negative 5 to 10 by multiplying by 2. So what I'm going to do is this first equation, I'm going to just copy over here, right? I'm not going to do anything with it. It stays the same. 2x plus 10y equals 2. And what I'm going to do is multiply equation 2. I'm going to multiply the entire equation by 2. When I do that, I multiply every term in the equation by 2. So 2 times 3x, that's 6x. 2 times negative 5y, that's negative 10y. And 2 times negative 17, that is negative 34. Okay, so now I have my equations are lined up, and now I have opposite terms, 10y and negative 10y. Those will cancel each other out. So let's add. What's 2x and 6x? That's 8x. Those y terms cancel. It's what I want to happen. They eliminate. And on the right side of the equation, 2 and negative 34, that is negative 32. Now I solve for x by dividing by the coefficient, and I get x equals negative 4. X equals negative 4. Okay, so how do I get y? Well, I got to take this x. If you know what x is, you can plug x into either one of your original two equations and solve for y. It doesn't matter which equation you choose. I'm going to pick equation number 1. Equation number 1 was 2x plus 10y equals 2. I'm going to plug x in right there. So 2 times negative 4 plus 10y equals 2. Just follow order of operations here. I got to multiply first. 2 times negative 4 is negative 8 plus 10y equals 2. I got to get y by itself, so I add 8 to both sides, add 8, so that those 8's cancel, right? Negative 8 plus 8, that cancels. So on the left side of the equation, all I have is 10y, and on the right side I have 2 plus 8, that's 10. So 10y equals 10. How do you solve for y? Well, you divide by the coefficient. You divide by 10 to get y equals 1. So what's your solution? If you know x is this and y is this, what is your x-y coordinate pair that satisfies the system? It's negative 4, that's my x-coordinate, and 1 is my y-coordinate. Negative 4, 1 is the solution to the system. Okay. Number 13, I will help set up for you, and then you'll finish solving. System 13 looks like this on your paper. Equation number 1 in the system is 2x minus 4y equals 18. Equation number 2 is negative 5x minus 6y equals 3. Okay, now I'm looking for, are these equations lined up? Well, I have my x's, have my y's, have my constants. Yes, they're lined up. So now go to O. Do I have opposite terms? 2 and negative 5x? Nope, those are not opposite terms. Negative 4y, negative 6y? No, they're not opposite terms. So I don't have opposite terms. I need to create opposite terms. Can I get 2 and negative 5 to the same number? Is there a common multiple between 2 and 5 that you can think of? 10, right? Can I get 2 to be 10? Yeah, I can multiply by 5. Can I get 5 to be 10? Yeah, I can multiply by 2. So what I'm going to do is I'm going to multiply the top equation. I'm going to multiply the top equation by 5. And the bottom equation I would need to multiply by 2 to get 5 to be 10. Okay? So let's write my new equations. My new equations are going to be written over here. Remember, if you multiply the equation by number, you got to multiply every term in that equation by that number. So 5 times 2x, that's 10x. 5 times negative 4y, that's negative 20y. And 5 times 18, 5 times 18, that is 90. Okay, now for your second equation, 2 times negative 5x, that's negative 10x. 2 times negative 6y, negative 12y. And 2 times 3, that is 6. Okay. Now when I'm looking at my equation, I see opposite terms, 10x and negative 10x. Those are opposite terms. So let's add my equations together. Those eliminate, right? 10x minus 10x, that's 0. Here you have negative 20y and negative 12y. Well, that's negative 32y. And then here you have 90 plus 6. 90 plus 6 is 96. I've got to solve for a y right here by dividing by the coefficient. Coefficient's negative 32. And so y equals negative 3. 96 divided by 32, that's 3. And I'm going to have a positive divided by negative, so that's negative. Negative 3 is my y term. So how am I going to get x? Well, you take this and you sub in. You sub y into either one of those equations, equation 1 or equation 2. It does not matter.